So this chapter is related to the exploratory data analysis, and especially we are going to discuss about visualization. There are some charts that we are going to learn. Of course, it is not all charts, okay, but at least you have the basic idea how to create the charts in the Jupyter notebook. First, don't forget to import the library. I guess we already know that those two uh, libraries, Numpy and Pandas, they are the two important libraries in data science. Okay, so we are going to import those two, and yeah, in this session, I will use Seaborn. I think we also used this Seaborn in the previous Jupyter notebook, and we are going to use one data set from this SNS. So this is the Seaborn library. And I'm going to look the iris data set. We already know about the iris data set, and we need to use load underbar data set in order to get the data set. So there are many data sets available in Seaborn. One of them is iris. So we are using the iris data set for this session. So we already learned about the basic Matplotlib concept. Okay. So last time I mentioned to you, it is a comprehensive library for creating static, animated, and interactive visualization. And if you want to see the documentations, you can see here, there are many visualization that you can use. Let's say if you go to examples here, you can see bar label demo, and then stack bar chart, group bar chart, and etc. And they provide the code. Of course, yeah, you need to understand the code by yourself. I'm going to explain the basic idea for this kind of visualization with the iris dataset, and there will be some other dataset that we can use for this visualization purpose. So the Matplotlib, it provides an object-oriented API, and it is for embedding the plot into applications, and it is for the GUI. So if you join the computer programming class, I guess you know about GUI. It is graphical user interface. So we can make the combo box, we can make the text box, we can make the check box, and etc. In Python, they also have that kind of GUI. They have like Tinker, okay, we call it Tinker, and then WX Python, Qt, GTK, yeah, they are the GUI toolkits in Python. And yeah, some of them are using PyLab for MATLAB or SciPy. Okay, so there are many libraries that connected to Matplotlib. So the way to import the Matplotlib is commonly like this one. We are using the Matplotlib, okay. And then in Matplotlib we have one function. We call it pyplot. Okay. So the pyplot is the Python for plotting, and we are going to make as an alias PLT. So everything with the PLT, it will be related to the Matplotlib. And the visualization tool, it requires a kind of, as I mentioned to you, user interface, because the user interface is available with some specific tool like what I mentioned to you, Tinker and yeah, Tinker or WX Python, Qt and GTK. So if you use Jupyter Notebook, you need to put this line, Matplotlib inline. So whenever you show the visualization, it can be shown directly in the Jupyter Notebook. If you don't have this Matplotlib inline, you cannot see the result. Even though your code is correct, but there is no visualization. Okay, so you need to put this line in order to see the result. Oh, sorry, maybe I need to run. Wait a moment. Okay, yeah, this one I need to run the Seaborn, and then I need to get the iris dataset, and yeah, I need to run the matplotlib and iris.head. Okay, I guess you already know what is the meaning by iris.head. Okay, iris means the variable that we are using for the data set. Okay, so this is the variable that we want to use for doing the analysis. And we are only seeing the first row, the first 5 rows from the data. And you can see this is the index 0, 1, 2, 3, 4. And we have 1, 2, 3, 4, 5. We have 5 attributes. Now you can separate what you want to see based on the rows or based on the columns. Okay, so let's say I want to create iris 1. Okay? In the iris 1, if you still remember LOC, you still remember? We have the ilog and log. Okay, so in the previous Jupyter Notebook, we learned about ilog and log. Okay. So if you use the ilog, it is based on the index. Okay, and it is based on the log, LOC. It is based on what the number that you want to refer to. Okay, so you can take a look on the material that we have before. So I would like to use the log. Okay, what does it mean by this one? Colon. Yeah, all. Okay, thank you. Okay, good. Thank you. So we want to see all the row. Okay, and then after we have the all row, we separate with the comma. So we have this one, sepal colon petal width. What does it mean? Any idea? So okay, from length to width. Okay, so from sepal length to petal width. Okay, from sepal to petal. Okay, okay, that's correct. Okay, so it depends on your data. It depends on your attributes, how you put the column. Okay, so if I have this column, sepal length, sepal width, petal length, and petal width, so it is already in sequence. So if I want to show the attribute from sepal length until petal width, then yeah, I will show all the columns. If I want to see sepal length until sepal width, then I will choose only these 2 columns. Okay. Okay, that's good. It's good to see all your participation. Okay. Now this is the basic plotting. Okay. We call it plot because it is already embedded, okay, in Matplotlib, and you can use the variable. For example, here, if I have a question, so Q, it means question, or yeah, if I give you like kind of question in your exam later, or question in the assignment, okay, so you can see that yeah, the question is do linear plot for all attributes. Then you can just use the variable name dot plot. It means you will see the plot for all the respective numerical data. Okay. So the plot here, it is for the numerical data, and yeah, because the data already set this one, the numerical data is the X, or we call it, this is the explanatory variables, and we have the categorical data is the species, is the flower type. Right? So the plot automatically show like this one. The red color is the petal width, the green color is the petal length, the orange color is sepal width, and the blue color is the sepal length. And this is the data. We have 150 data, and this is the attribute. Okay, that's one question. Sepal length to petal width means sepal length to petal width column, but can I type and value for its column to show? Yes, you can type the index, okay, like 0, 1, 2, okay. But of course, okay, let me show you. Okay, so if you show this one, you can see the sepal length at the sepal width. Okay, if you want to use like okay, you can use index actually, but it is not recommended with the index, because when you use the index, it is sometimes they cannot recognize the column index. Wait. So it this kind of okay, sorry. So you can see the slicing with the indexer usually is not working well with the column, okay? Because the column, there is no kind of index like the row. So if you want to use the index, it is only for the row. But if you already define the index, okay, so in this case I do not define the index, so you cannot use index for the column. It is better to use the column name. Okay, so the column name will be better to express the how you want to show the data, because if you use the index, it means like you need to define columns. Okay, so the columns, then you can define like sepal length. Okay, so you need to define this one is the index 0, and then what is the index 2? What is it? Sepal width. So this is the index 1. Okay, and then yeah, you need to define the petal length and so on. Okay, so if you define with the columns like this, then you can have the index 0, 1, 2, and 3, and then you can use it for the column. But if you don't have this definition, yeah, it's better to call with the column name. Okay, is it okay? Does it answer your question? Okay. Okay. Thank you then. Yeah. If you have any question, then just chat me. I hope that I can see your question and I can answer directly. Okay. Thank you, Kang Hyunwoo. Okay. So let me just go back this one. Yeah. Because I know the column name, so it's better to use the column name instead of the index. So this is the plot. Yeah. And when you use the plot, you can use kind. What is meaning by kind? So kind is a function to distinguish the plot result. So you can have many kind. Okay. So plotting methods allow for a handful of plot styles other than the default line plot. So the default is line plot, but you can define for histogram with HIST per or per H for per plots, box plot, yeah, and then KDE or density for density plots, area for area plots, scatter plot, hex bin hexagonal bin plot, pie plots with pie. Okay, so you can define the kind with this kind of plotting. So let's see. For example, I want to show the histogram. Okay, and the histogram is a kind of two axes. Okay, we have x and we have y. So I can show you only the simple histogram at this moment. So you need to define the type of chart. In this case, I will use histogram. And then I need to define the x and I need to define the y. Let's say I want to use the x as the species. Okay. Actually, yeah, this is I want to check I think this is the number of the species, and then the sepal length. Yeah, we have like the numbers, yeah, the numbers of the sepal lengths. So if it is in between 4.5, yeah, they are like 8. Yeah. So this is the default is 10 bar. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So in this 10 bar, it means the maximum is about 8, okay, and the minimum is about 4 something. Okay. So they start from 4 until 8, and in between 4 until 8, they make like 10 bar. So they distinguish equally 10 bar, and they calculate how many of the sepal in between. Yeah, maybe this one is 4 until 4.5, and then yeah, in this case, how many of sepal in between 4.5 until 5, and so on. Then we can see like the distribution. Okay. If we want to make the bins more than the default, in the previous chart, we see that the bin is 10, but now I have 20. Okay. So you can see that in between 4 until 8, yeah, there are 20 bin, or there are 20 bar. Okay. And you can see more result. Okay, so in between 4 until 4.5, there are yeah, we have 4, and then here we have like 5. Oh, so maybe the previous one we have 9, okay, and so on. So this one is more detailed. Okay? But of course, if you make many bins, yeah, it is more complicated to see. If you make smaller bin, it is too. I think it's very the summary. You can say it is the summary, but maybe you cannot do more analysis with the summary if it is too small. So you need to set a proper bin. Of course, it depends on the data. For the iris data set, the bin equals to 10 seems like good enough. Okay. 20, yeah, this is still good, but it's quite a lot and it may have some complicated analysis. You can change the color. Okay. So if you have the kind histogram, X is the species and Y is the length, and then I make the pins equal to 20, and then red equals color equals to red. Yeah, so you can change the color like this one. And we call this is the parameter. Okay. So the parameter, yeah, you can take a look on the documentation. Okay. For now, I just give you some examples. Of course, there are many other kind of parameters. I cannot explain all those things in this class. Yeah, if you want to take a look, you can try to figure out more about this. Now, if you want to see the what we already see before, okay, about the histogram, the previous one is only for the sepal length. Okay, so we have only the sepal length for this one. But if you want to plot for all the things, yeah, you can just leave the other parameter. So you don't need to specify the X, you don't need to specify the Y, okay, and you can just plot the histogram. It plots every of the numerical variables, and it specify directly about the categorical data like this one. Sorry, not the categorical data, but this is based on the attributes. Okay? So the red color is the petal width, the yellow, the orange, yeah, is sepal width, the green is the petal length, and the blue is the sepal length. So it shows all the data at once. Okay? And it shows the frequency. It means the petal width in between 0 until 1. Yeah, we have about 50. Yeah. So there are about 50 flowers where the petal width equals to 0 until 1. So in between 0 until 1. And you can see the sepal length is mostly high. Okay. The petal width is mostly small. Okay. And the sepal width is, yeah, in the middle, and the petal length, yeah, it is diverse. So we have like broad measures for the petal length. Yeah. So you can do more analysis with this one, with this visualization. Of course, when I give you like a kind of question, you need to try to explain. You don't need to explain many things, but yeah, you can just say like, okay, in the petal width shows the smaller size. The sepal length shows the bigger size. Okay, so that will be enough. Okay, for example, yeah, I can say the petal width, yeah, shows the smaller size compared to other attributes, and the sepal length shows the bigger size compared to other attributes. So you can do this kind of analysis when I give you questions related to this visualization. Okay, so if I ask you like explain, okay, then you need to explain like this one. Of course, this is only the qualitative. It's not easy to see the number, okay, but that kind of analysis is enough. You can do something different. Okay? If you see the previous one, okay? The previous one we use the plot. Okay? So we use the plot with the kind. So we have the iris dot plot, and we have the kind equals to his, and then we set the x equals to species, okay, and then the y equals to sepal. Okay? Actually, there are many ways for this visualization, and you can get almost the same, or the same result. In this case, the result is the same with this one. And here I just want to use the iris, the column name, which is sepal, and then I want to plot into histogram. Okay? The result is the same. So it means, you can use any of the code for your visualization. You can also set the bins. Okay? In this case, we have the histogram, and then we define the parameter inside the brackets. So we define the bins equal to 20, and then the color you can change to green, for example, and we want to just use the sepal attribute. Okay, so that's about the histogram. Okay, so when we use the histogram, we are combining the the x-axis is the numerical, okay, and y is the frequency, okay, or the number of the numerical data in the data set. Okay. So in the case of box plot, okay, so in the case of box plot, we want to draw the box plot with several kind of ways. Okay, if you still remember, we have series and we have data frame. Do you know what is the difference? Do you still remember what is series and what is data frame? Nobody remember? Okay, one series is a factor, data frame is n multiplied by m. Okay, okay, thank you. And the other answer is combination of row column data. Yes, I think, yeah. Shin Young, thank you for your answer. So your opinion is closer to the answer. So in the series, we can call it factor, okay, or we can call it is one dimension, okay, one dimensional data. For the data frame, it is multi-dimensional data. Okay, so yeah, you're correct. And xm. So first I thought What is nxm? Okay, I know, I understand. N multiplied by m. Yeah, it's multi-dimensional data. Okay. If you use the series, you can use the box plot only for one column. But if you use the data frame, when you use the box plot, you can see several data. Okay. So for example, this one, when I use the iris plot.box, okay, so I can see that iris is a data frame. Okay, am I correct? Yeah, if you take a look on this data set, it is a data frame because it contains of sepal length, sepal width, petal width, and the species. So it is a multi-dimensional data because we have several columns. So when we plot using the box plot, so this is the box plot result. So this is the distribution. Okay, so the sepal width shows the lowest size or the lower size, and sepal length shows the bigger size. Okay, so it's the same with the histogram that we saw before. And in the box plot, we have this line. Okay, this is the, do you know what is it? The line means the, not mean, but the median. Okay. Oh, thank you. Good. Yeah, everyone's know already about the box plot. Okay. So the line is the median. Okay. And then we can have another information like this one. So within the box, okay, so we have the Q1 and Q3. Okay, good. Thank you. Thank you. Okay, yes, you are correct. Okay, Q1 and Q3. Okay. So when we have this box plot, we can see that, okay, the Q1 is here and Q3 is here. Okay. And then this is the maximum and this is the minimum. Okay. Okay. Oh, I guess you already know all these things. Okay. So the box plot can be colorized. Okay. So I just want to show you some alternative how to show the more colorful visualization. Okay. So you can pass a dig, it means a dictionary, okay, whose keys are boxes, whiskers, medians, and caps. Yeah. If some keys are missing in the dictionary, so the default colors are used for the corresponding artist. So you can make the colorful of the box plot. And the box plot has SYM keyword for specify flyer style. I will show you some of the way to make it more pretty. When you pass other type of argument via color keyword, it will be directly passed to Matplotlib for all the boxes, whiskers, medians, and cap colorization. And the colors are applied to every boxes. So if you want to have a complicated color, you can get its drawn artist by passing return type. So if you understand how to make the function, okay, when you use function, then you can have function with return or function without return. We already learned the basic one in the chapter 1 of this Jupyter notebook. If you want to use more complex with the parameter for colors and the size and etc., yeah, you can use function with return type. Let me show you some of the parameter like this one. Okay, so I have the color and I need to define the key is boxes. So the boxes color will be green. The whiskers, okay, So the whisker means this line. This line is the whisker. Okay. And then the median is this line. And then caps. Okay, caps is this one, the caps. So you can specify the color based on those parameters. And once we make this kind of dictionary, I define boxes equals to green, whiskers equals to dark orange, medians equal to dark blue, and caps equal to gray. So when I plot it into the box plot, if I put the color equal to the color and the sim equals to R plus, okay, so everything will be shown something like this one. Okay. If you want to change the the visualization format of the box plot, you don't want to see the vertical, but you want to see the horizontal line. Then yeah, you can say the vertical equals to false. Then the box plot will be in the horizontal. Area is another plot. Okay, we can use this series dot plot area and data frame dot plot dot area. Okay, and area plots are stacked by default. And to produce the stacked area plot, yeah, its column must be either all positive or all negative values. So it depends on your data, of course. In this plot, we want to see the plot in the area. So the blue color is the sepal length. So we have 150 data. Okay, we have 150 data, and then it shows the measures. So this blue color, we know this is the sepal length, okay, and then this is the petal width. Okay. So it means the sepal length shows the higher one, okay, and the petal width is showing the small one. So this it shows the area among all the values. Okay. So this one is sepal length, sepal width, petal length, and petal width, and it shows the area fully of this area. So using this kind of data is a little bit meaningless with this area plot, but maybe it is good to see with other kind of data. Okay. So this is meaningless. There is no meaning with this area plot, but at least you can see that the area plot works with the numerical data. Scatter plot. So this is important plot for doing the analysis with two axes, x and y. Okay. It is necessary to define the attribute for x and y. Okay. And we can define the attribute name because we have only two. Okay. We have only two, which is x, and we have y. So if you do not define the x and y, then the scatter plot will not work. Okay. So in this case, I want to plot, and the kind of the plot is scatter. And the x is sepal length and the y is petal length. Then yeah, you can see the sepal length and the petal length, and then this is the plot result. So you can see the sepal length is mostly low compared to the petal length, and then the other seems high. Yeah, you can do with this as well. Iris.plot.scatter. Okay. So in the previous one, we used the kind scatter. Use the kind.scatter for this one, but if you don't want to use the kind.scatter, yeah, you can use the plot.scatter and then define the x and y. So the result is the same. If you want to make a group. For example, the iris.plot.scatter, I have the X, I have the Y, and I want to make the color. Okay. So the first will be the sepal length and the sepal width that with the blue color. So this is the group one. And then you want to put another data, which is petal width for the X and the petal length for the Y, and shows in the dark green color. And you want to put it as the label with the group 2 and combine with the AX. So AX is this one, AX. So you can see the plot for this one is the petal width and the petal length, and this one is the sepal width and the sepal length. Okay. So you can show the scatter plot with two ways, like this one. Or yeah, if you want to do the size, okay, so the size, the blue is the color and the size is 100, so you can see the dot is bigger. And if you want to show based on the species, okay, then yeah, you can see that the species is the, you use the facet grid. Yeah. Okay, maybe I will stop here because we are going to do the quiz.